So this is an answer to the second part of the answer written to this viewer. She left this in the comments. Consider for every real number a the linear system of equations, these three equations down here at the bottom. Find the values for a for which the system has no solution, infinitely many solutions, and a unique solution. And my way of going about this, and I'd like to know what class you're in. This looks like an advanced algebra class in college, but my way was to use the linear algebra matrix, to use an augmented matrix. And I wanted to get to this point where I got my x equals whatever I get here, my y equals whatever I get here, my z equals whatever I get here in this fourth column. And these are all going to be in terms of a, but I'm treating a as a constant. Let me go to the next page. This is where I left off on the last video, but there's a little error. I had a minus sign here, and it's actually a plus sign. So you want to go back and check that, and that was the answer going here. And then you have to do this stuff again, which was r1 plus a negative a minus 1 times r2. And for some reason, every time I put a r there, it doesn't write. But anyway, it goes in this slot, and I'm going to show you the worked out solution on paper, or this is scanned in from what I wrote on paper. This is the next step. So down here I'm pivoting off of this now, and the first thing I need to do is I need to make this 1. So for that step, think about what you have to do. You have to take this element and divide it by itself, and you get 1. So I'll take row 3 divided by a minus a squared, and I'll put that back in row 3. That's what I'm replacing row 3 with. So when I do that, I get a 1 here. This changes. I'm dividing by a minus a squared now. So you have to go through and do those individual calculations. But now I'm pivoting off of this. I got the 1. I need this to be 0, and I need this to be 0. So to do that, I need to multiply by a linear combination of this third row. So the next one is r2 minus row 3 times this stuff, which is the stuff right here. And I'm basically subtracting this minus itself is going to be 0, and then I have to do it right here too. Now if you do it with these two columns, it's going to work out good, because I end up subtracting by 0. And write that out, and you'll see what I mean. You have to write each individual one out, because this is otherwise going to be very tedious to explain. So at this point, watch the first video, and if you understand the steps I'm going through, you should be able to do those calculations. So anyway, when I get to now I get to this point where I have a 0 here, and I have this has changed. I have a whole bunch of stuff here, which I'm not going to worry about simplifying. I think if you try to work it out and start simplifying, it doesn't really help you. And you'll see at the end why it's not necessarily that important. Row 1 minus row 3 times this stuff, which would be the stuff here, that gives me a 0 here. So in my finished part of the matrix, anyway, the matrix is finished. I got what I wanted, the 1, 1, 1, and so x equals this stuff, y equals this stuff, z equals this stuff. And my problem points that I want to look at are when I end up dividing by 0. So if if 2a minus a squared equals 0, then I have a problem. You can't divide by 0. The fraction is dividing. So I want to look at at those points, and those are going to be my critical points to look at to see, well, when is there going to be no solution or infinitely many solutions or something like that. So I have to factor. So basically I'm setting it equal to 0 and I'm factoring. A minus a squared equals 0. I factor out of a in this next line and I get a times 1 minus a equals 0. So it's either, to multiply together, one of these have to be 0, either a or 1 minus a. So a is 0, or if 1 minus a is 0, then a is 1. So or a is 1. That's not a negative. That's just a straight mark. And I do the same thing for a squared minus 2a equals 0. I factor out an a, and that's all I get. 0, a equals 0, or a equals 2. But I already established the case for a equals 0 being a point I need to look at. And thirdly, I get a equals 0 and a equals 2 again. So the 3 points that, or at least the critical points, are 0, 1, and 2. So let me switch windows and let's look at these. So this is back to the original equation. That's what this is. And when I replace a with 1, now I changed this a little bit from the PDF. I had an error in it, but so when I replace a with 1, now a is a constant like we wanted it to be. So 1 plus 1 is 2, so here that's why I have 2y. And everywhere I see a, I'm putting in 1. So 1 minus 1 is 0. 0 times x is 0, so I eliminate that x term. And what I get here is this system of equations. There is a z here, and it won't write, but that system is something I could put into a matrix. Now you'd have to take the steps to go through and solve yet another matrix, this matrix up here. But hopefully, you know, you can put that into a TI-83 plus and do it, or do it out by hand. It's the same thing, and it's not nearly as difficult because you have just numbers. And then here, more technical difficulties. This is a 2, and you see it won't show up. The 2 there. So at any rate, I see my problem. What I get is all zeros on the bottom. So in that case, I'm gonna have no solution for I'm sorry, I mean, in that case I have all zeros at the bottom, so I can let my z be free. So z can be whatever number I want. I have that my y is going to be -1, and then from there I can figure out what x is, and the way I do that is, so like I said, z, I'm just getting messy with this. It's a big problem. Z could be anything. Y equals -1. I read that here. This is I need a 1 here and 0 in the x and y. I can read this is the y slot, so y equals whatever is here. So y equals -1, and then the x, well, this equation, like I said, is a 2 here, so it's plus z, I'm leaving off the z, equals 1. So y is negative 1, so I'll put a negative 1 here and get plus negative 2 or minus 2, but whatever number I choose for z, now you see I can solve. You had to pick a number and put it in for z, because any number works. Then I can solve for x. So then when I go and I pick a different number for z, I have another solution. So here you have many solutions. So this is the case when a equals 1, here, and I have many solutions. Now, if a equals 0, what happens is I get some canceling out. A equals 0 here, so I have no z in the first one. And here I never had a z. When I put in 0, I get just x here and just y here. That's the same equation. I have the same equation listed 3 times. So this is the case where I have many solutions, because I just have one equation. So that is just like a line where I got y equals minus x. So anyway, this is something where when you solve for y equals minus x, so y has to be negative x, z is 0, and I have many cases. The next one, a equals 2. So when a equals 2, I get equations. If I go to solve those, and I'm solving them in matrix form, putting it in the calculator, but I get this at the bottom, 0, 0, 0, 1. So there is no z, and that is a problem. In that there is no solution. I need a number here. So since I end up with just 0, there's no z. What does z equal? So that is a problem, and there is no solution. So here you have y equals minus x, or x equals negative y, and then what was the other case? The other case I had where z could be anything, y equals minus 1, and then x changes depending on what z is. So that's the whole question. Now there's a lot to this question. There's a lot of steps. So go through, look at each part, and on each part, it just disappeared. On each part, check and make sure all the calculations are right. And I can send you that PDF. I'm not sure if I can put it at the link on or at the bottom of the description, or I can email it to you. You can email me at btitushopkins@gmail.com. btitushopkins gmail.com. Not .com. I appreciate the question. Let me know how it works out. You may be taking an exam now. And I can email you the PDF. Check out my website, weebly.upstatemathtutor.com. You can find a link on the YouTube, and if you want, leave me a donation. Thank you.